Hello everyone. In this tutorial video I am explaining the branch instruction of the ARM processor. A branch instruction is nothing but it will going to break the normal sequential flow of instruction that the processor is executing. So some other architecture call them as a jump instruction, but they are essentially the same thing. So there are several variants of branch instructions in the ARM and the thumb instruction set. We'll see about the branch instruction, the variants of the branch instructions in the ARM instruction set. So we're going to have a different variants. We'll see one by one and let's check how exactly it will going to work. So now the first one is a B, which is an unconditional branch instruction. So when I say unconditional, it will not going to check any of the flag bit while executing this instruction. So whenever the ARM program will going to encounter a B instructions or a branch instruction, the label, the address which are specified in the label will be copied to the program counter, and the program counter start executing the processor will going to start executing the instruction specified by the program counter. So we have one more variant called as a branch with link. So what is the difference between a branch and a branch link? So when the program encounters a subroutine, so when processor wants to jump to a subroutine, so now when after executing the subroutine, it has to come back to the main program. So at the end of the program, I'm going to use this instruction move PCR LR. So where LR should know the address where exactly the processor stopped at the main program after executing this branch instruction. So now after the executing this branch instruction, whatever the instruction that is in the main program, that address will be copied to the link register. So when the processor comes from the subroutine to the main program, the program counter is loaded with that address and the processor starts again its normal execution. Now there is one more variant which is called as a branch exchange. So through this branch exchange, the processor state can be changed from ARM to thumb or else from thumb to ARM. So let's see how it will going to work. So we have a general syntax over here. So along with all these variants, I can use any of the conditional execution mnemonics such as not equal, equal, carry set, 0, any like that, any kind of an conditional mnemonic can be used here. Along with that, we have whenever we encounter with a B and BL instructions, there will be a label, and when BX and when we want to change the ARM state to the thumb state and from thumb state to the ARM state, we are going to have a register. So there may be a label or an RM register. So one more thing is the last bit of the RM register, that is bit 0, will going to decide whether the processor changes or remains in the ARM state. So when the bit LSB bit of the RM, so this register, so which will going to have the address again, which will store the address to which the program counter has to jump or the processor has to jump in order to execute that. So it will decide by this RM register. So if the LSB bit of the RM register is 0, then the processor changes or remains in the ARM state itself. So if that LSB bit is 1, the processor changes to thumb state or remain in the thumb state itself. So these are some of the branch instructions that we encounter in the ARM processor. Let's check. So I have written a simple program here for B and BL. So I can just remove this one, EL. So I'm going to save this. As I told you, this branch instruction B is unconditional instruction. It will not going to check any of the flag bits in the CPSR register while making a jump. So I'm just loading here. See, as you can see, the program counter starts with a 00, the address 00. When I execute the first instruction, it will be pointing to the next instruction 004. As you can see here, each instruction will going to have an address specified in this assembly. So now, so without checking any condition, it will going to jump to the label skip. So what is this address of the skip? So as you can see here, yes, this one, the address is 20. Now the program counter is directly loaded with the address 20. As you can see, this will going to be skipped by the processor. As soon as the program counter will have the address like 20, it will start executing from this instruction now. So this is how the B instruction will going to work. Let's come and check for the BL. See, I forgot to show you one more thing. See, as you can see, when I executed this instruction, the link register has nothing to do with this instruction. That means whatever the next address of the instruction after the B encounters or the branch instruction, the instruction next to the branch instruction address will not going to be copied in the LR register, which is the link register. So now when I use a BL instruction instead of B, that means I have simply took the jump from these instructions, but while executing a subroutine. So when you want to assume that this is your main program and you want to call a function or a subroutine, so the program counter is loaded with a subroutine address and it will start executing that. So when after the completion of the subroutine, the processor should come back to the main program. So at that time it should know exactly where it stopped the execution of the main program. So in order to do that, I'm going to use the link register. Sorry, I just didn't save that one. Now it will going to work. See, as soon as program counter will next be loaded with a value 20, as you can see, the next instruction, this was 0000 and this was like 004 and this was like 0008. So this address, the address of the next instruction immediately after the BL instructions will get loaded into an LR register. Now the processor, assume that the processor is jumping to a subroutine. So after and remember one more thing, the last instruction of the execution, the last instruction of the subroutine should be like this one, move PC comma LR, so that this link register address should be get copied to the PC, and after executing the last instruction the program counter should come back here. So this is about the BL and BX. I'm not written a program for a thumb mode, that is a 16-bit mode. That's why I'm not showing in this example. I'll come up with a next video for that. So this is how these are the variants of the branch instructions in the ARM processor. You should remember that B and BL will going to jump to the relative address. So if the relative address is like 00, it will going to do a forward jump of 32-bit MB and 32 MB and a reverse jump of 32 MB. So this is how the instructions in the branch instructions of ARM processor will going to work. Thank you very much.